This is an explanation of integrals that lead to inverse trig functions. The rules come directly from the derivatives of inverse trig functions, which we would have looked at last time, and the idea here is just basically to fit your integral to one of these templates if possible. So you're going to want to refer to the templates that will integrate the inverse sine, inverse tan, and inverse secant. So for this particular integral, if it's rewritten in this fashion, where e to the 2x is e to the x quantity squared and 1 is 1 squared, you have an a is equal to 1, and u is equal to e to the x, and the du is e to the x dx. So what we can do is put the e to the x on top, e to the x on the bottom. Look at this how it is. And now this fits the template for inverse, it looks like this, which fits the template for inverse secant. So you've got your 1 divided by a, and then your inverse secant of u divided by a plus c. This is a situation where first we have to complete the square, and so we do half of negative 4, which is negative 2 and squared, we get 4, so we split the 7 into 4 and 3, and so now this becomes x minus 2 squared, this becomes rad 3 squared. If u is x minus 2, our du is dx, so we're fine there, and our a meanwhile is rad 3. This fits the template for inverse tan. Over here, again, we've got to complete the square. So we factor out a negative, and then half of negative 3 is negative 3 halves. So square, we get 9/4. So we subtracted 9/4 because it's a negative, so we've got to add it back. Now I can rewrite it in this fashion. So now our u is x minus 3 halves, our du is dx, so we're fine. A is 3 halves, and this fits the inverse sine template. Okay, more examples. This integral here is going to be arc sine of x over 2, because our u is x, our a is 2 squared minus a squared, from 0 to 1, and we have arc sine of a half minus arc sine of 0, so that's just pi over 6. So here's our u is x, and our a is equal to 2. Okay, this situation, we have our a is equal to 3, our u is equal to x, so it's 1 over a, arc tan of u over a. And so then we plug in our limits. We have 1/3 arc tan of 1 minus arc tan of rad 3 over 3. So 1/3 pi over 4 minus pi over 6, pi over 36. For this particular one, again, we have one thing squared plus another thing squared. So this is going to be an arc tan. So we have 1 over a, because look at this is 2 squared. And we've got our arc tan, and we have u over a. So here's our u squared, this is our a squared, so x minus 1 over 2, and then of course a plus c, since it's an indefinite integral. This one, oddly enough, doesn't require integrating to an inverse trig, it requires differentiating inverse trig. So here's our original integral. If you let u equal arc cosine x, the du is negative dx over rad 1 minus x squared. Well, I have a dx over rad 1 minus x squared, I need a negative. So you put a negative here, so negative on the outside, and then what I did was, I take these parts in blue, that becomes my du. I take the part in yellow, that becomes just a u. I also change my limits of integration. You've got to plug in arc cosine of 0, get pi over 2, arc cosine of 1 over rad 2, get pi over 4. And now, last thing I did is I took the negative out and I switch my limits of integration. You don't need to do that, but I like to go from lower to higher. And then it's just a power rule. So you get half u squared, you plug in your limits, and you get all the way to 3 pi squared over 32. This example, I did this ahead of time, just take it one bit at a time. If you look at the bottom, u equals x squared plus 2x plus 2. If you want to du is 2x plus 2, you can integrate that as du over u. So what I did is I took the 2x minus 5 and made it 2x plus 2 then minus 7, because you have to, of course, get minus 5. So then I rewrote it in this way, split into two integrals, left one and right one. Now, the left one, as you see over here in blue, can come all the way down here and becomes a u substitution, du over u, so you get rid of x squared plus 2x plus 2. You don't need absolute value because this is always positive. Now the right side, I took the 7, put it out front, and then this integral here, you complete the square, x squared plus 2x plus 1 plus 1. My u is x plus 1, my a is 1, so I get down to here, and then this is an inverse tan. So I split it up, I've got a natural log on the right, I've got an inverse tan on the, natural log on the left, inverse tan on the right.